This lesson is on mixed problem solving with all operations. First, we'll start out with addition. In addition word problems, you'll have situations where you are either combining two things, finding out how much two things add up to be as a total or all together. You will be finding a final amount after you add something on to an original amount. We're going to go over two examples together. The first problem says Willis had an AR goal of 25 and 9/10, but Harold's goal was 16 and 2/10 points more than that. What was Harold's point goal? For this problem, we know we're starting with 25.9, and then Harold's goal is 16 and 2/10 points more than that. Anytime we see more than that, we know that we're going to add. So when they ask for what was Harold's point goal, we know that we are going to take the starting amount of 25 and 9/10 of Willis's goal, and we're going to add 16 and 2/10 more onto that. So to solve this problem, you'll line up 25 and 9/10 plus 16 and 2/10. Since you're adding, you make sure you line up your decimals. Bring your decimal point straight down. 9 plus 2 is 11. 1 plus 5 is 6. 6 plus 6 is 12. 1 plus 2 plus 1 is 4. So that tells us when the question is asked what was Harold's point goal was 42.1. The next addition example is the element sodium has an atomic mass of 22.99, or 22 and 99/100ths. The element chlorine has an atomic mass of 35 and 45/100ths. What is the combined mass of the two different elements? Okay, we're going to start underlining what we know. First, we know that sodium has a mass of 22 and 99/100ths. Chlorine has an atomic mass of 35 and 45/100ths. Then the question asks, what is the combined mass of the two different elements? Since we are combining two things, that means we are adding. So just like in the top problem, we're going to add our decimal numbers, 22 and 99/100ths plus 35 and 45/100ths. And make sure you line up your decimals since you're adding. 9 and 5 is 14. 1 and 9 is 10. 10 and 4 is 14. 1 plus 2 is 3. 3 plus 5 is 8. And 2 plus 3 is 5. So your combined mass of the two different elements is 58 and 44/100ths. Our next operation we're going to go over is subtraction. Now with subtraction, a lot of times you are taking away from something. Subtraction can be taking away an amount from a total, or you're being given a total and you have to find a missing amount. Make sure you don't confuse that with division, because division is where you start with a total and break it into even groups. Subtraction, you might start with a total and you might be asked to find a missing amount. Subtraction can also mean you're taking money away or withdrawing money from a bank account. It can mean you're getting change from the store, or you're finding how much less something has or how much more something has. So we're going to go ahead and start with an example. The first problem is Seattle's rainfall averaged a total of 3 and 8/100 inches for the month of March. If April had an average rainfall that was 82/100 inches less than March, what was April's rainfall in Seattle? So what we're first going to do, underline the information that we know. I'm going to underline 3 and 8/100 inches for March. And then April had 82/100 inches less than March. Since we see less than, we know we're going to subtract. And it says, what was April's rainfall in Seattle? So first we need to choose the larger number to go on top, which is 3 8/8 inches. It is larger because there's a 3 in the ones place, so you have 3 whole inches as opposed to 0 inches and 82 hundredths. So we'll write 3 8/8 minus 82 hundredths. And again, adding and subtracting decimals means we are lining up the decimal points. 8 minus 2 is 6. We cannot do 0 minus 8, so we need to regroup. 10 minus 8 is 2. And since we borrowed to make the 0 into a 10, our 3 will become a 2. And 2 is our whole number. So April's rainfall in Seattle was 2 26 hundredths inches. The next problem is Mark and Cheryl hiked a total of 12 8/10 miles on their weekend trip to Canaan Valley. If they hiked 4 8/100 miles on Saturday, how many miles did they hike on Sunday? So this starts with a total. This is one of the ones we were talking about where it does start with a total of 12 8/10 miles that they hiked on their entire weekend. So for their entire weekend, which was Saturday and Sunday, they hiked a total of 12 8/10 miles. We're going to start this one by making a little bit of a bar diagram, and these are very helpful, and I recommend you use them when you're deciding what operation to use. So their total weekend was Saturday and Sunday. That whole weekend, they hiked 12.8 miles. And on Saturday, they hiked 4 8/10 miles, or 4 8/100, I'm sorry, 4 8/100. So we need to know how many they hiked on Sunday. Now, if we look at this, we have Saturday and Sunday combined will equal a total of 12 8/10 miles. We have a missing number here. So since we have a total and we have a missing piece, we're going to subtract. Now, this is different from division because division is breaking it up into equal groups. This might not necessarily be equal groups. We have 2 days that we've combined to get a total, and we're just missing one of those days. Since we're just missing one of those days, that makes this a subtraction problem. So we're going to go ahead and set it up by carefully lining up our decimal points. The total, which is 12 8/10, goes on top. And then we are going to subtract 4 8/100. Now this is where we need to be careful because 4 8/100 has 2 places past the decimal point, but we still have to line up our decimal points. 4 8/100. Since I have no number at the top here, I need to add a placeholder 0. And I can go ahead and subtract. Though I can't do 0 minus 8, I'm going to have to borrow or regroup. I will borrow from the 8. The 8 will become a 7. Since we borrowed a 10, we're making that 0 into a 10. 10 minus 8 is 2. 7 minus 0 is 7. 2 minus 4 you can't do, but you can do 12 minus 4, and that will be 8. So your answer is 8 72 miles. Next, we're moving on to multiplication. Multiplication and division are two operations that use groups of items or groups of something. You have equal groups, and you are either finding the total or finding the amount in each. With multiplication, you have groups and then you're finding the total. So in this first problem, we have Jennifer is making costumes that call for 1 2500 yards of fabric for each. If she makes 14 costumes, how many yards of fabric will she be using altogether? Now, a big mistake that students often see is they use the word all together and they say, oh, I'm going to add. But you need to read the whole problem and we need to think about the situation. It says she uses 1 2500 yards of fabric for each costume. So this is where visualizing the picture or drawing a picture is really going to help. And forgive my drawing, but we're going to draw a little example of a costume. That's going to use 1 2500 yards. And in order to make all of the costumes, I would be doing 14 of these. Over and over and over until I drew 14. But I don't want to draw that many pictures. But if you get the point, we have 1 2500 here, 1 2500 here, and we're going to keep doing this 1 2500 until we get 14 of them. So we have groups of 1 2500. We have 14 groups of 1 2500, so that means we're going to multiply. So in order to do this problem, we have our 1 2500 yards of fabric for each costume, and we are making 14 costumes. And since we're multiplying, you can go ahead and push all of your numbers to the right. 5 times 4 is 20. 4 times 2 plus 2 is 10. 4 times 1 plus 1 is 5. Put your 0 in as a placeholder because we moved over to the tens place. 1 times 5 is 5. 1 times 2 is 2. And 1 times 1 is 1. 0, 5, 7, 1, and our decimal point looks like it's over 2 places. So when it comes to asking how many yards of fabric she will be using all together, she is going to be using 17.50 or 17 50 hundredths or 5/10 yards of fabric. Our last operation is division. Division is like multiplication because you're still dealing with groups of something. You're still dealing with equal amounts. So the main difference between multiplication and division is where you are starting with a total and you're breaking it up into smaller equal pieces. And typically your questions will ask how many in each or how many pieces are there. Multiplication, you're starting with your two groups and it's asking you to find a total amount. So keep in mind, anytime you are dividing, it's going to be asking for the amount in each or how many you can make from that total after you divide it up. So our first problem is Dave is an electrician who is trying to cut equal sections from a 15-foot piece of electrical tape to repair wiring. If he cuts the tape into 2.5-inch pieces, how many pieces can he cut? So he's starting, and this is where drawing a picture might help if you're not really sure of what to do. He's starting with this 15-foot piece of electrical tape. And he is making equal sections of 2.5 inches. And we just want to know how many equal pieces he can make. We don't really know how many equal pieces we can make, so I'm not going to finish the drawing. But in order to figure out the exact number of equal pieces he can make, because this is not an accurate drawing, this just shows that we have to divide this 15 up into 2.5-inch pieces. We are going to divide. So the total amount, the total length of the tape, is what is our dividend. So that 15 is going to go in the box. And we are dividing by 2.5 inches. And since it looks like we are dividing by a decimal, we have to use our rules for decimal division. We need to make that 2 5/10 a whole number. So we need to move that decimal point out of it. So the 2 5/10 becomes 25. And the 15, since there's no decimal point in there to begin with, we know it's going to be right after the 15. And it looks like for over here in our divisor, we moved it over one place. So we're going to need to move our decimal point over one place in the dividend also. So we're going to move our decimal point over one place. Since we don't really have a place to move it to, we're going to add a 0 here. So this number, once we moved the decimal point from between the 5 and the 0 to after the 0, is now 150. 25 goes into 150 6 times, and we can figure that out by making a multiple tower or guessing and checking. And we'll do guess and check to make sure we're right. 5 times 6 is 30. 6 times 2 is 12. 12 plus 3 is 15. And 25 times 6 is 150, and we have no leftovers. So he can cut 6 pieces of tape. And we figure that out by dividing. Our final problem is going to be a division problem also. Larry is traveling by train to Cleveland. The train has traveled a total distance of 146 25/100 miles in the last 2.5 hours, or 2.5 hours. How many miles per hour has the train been traveling? We're going to underline what we know. The train traveled a total distance of 146 25/100 miles, and it took 2.5 hours. And the question is asking how many miles per hour. How many miles per hour, whenever it's asking that question, is always going to be asking us to divide, because we are starting with that total distance and we are breaking it up into hours. And then that's going to tell us how many miles per hour the train has gone. So miles per hour is really just asking how many miles has that train traveled in each hour. So we're going to put our 146 as our dividend. 146 25/100 will be our dividend. And we are going to divide that by 2.5, or 2 5/10 hours. Since we're dividing by decimals again, we have to make sure we move over our decimal points. I moved it over one place in the dividend, so that means I have to move it over one place in the divisor, or I moved it over one place in the divisor, and I am going to move it over one place in the dividend. So now our new numbers, the 2.5 is now 25. And the 146 25/100 is now 1,462 5/10. Now I can go ahead and start dividing by bringing the decimal point straight up first. 25 can go into 146. Well, let's make a multiple tower of 25. This is going to make it easier. So we have 25, 50, 75, 100, 125, 150, 175, 200. And we'll stop at 225. I don't know if we'll have to go further than that. So we have 25 goes into 146. 1, 2, 3, 4, 5, 6. Nope, 6 goes over, so it's going to be 5 times. So we're going to put the 5 above the 6 in 146. Do our subtraction. 6 minus 5 is 1. 4 minus 2 is 2. And we're going to bring down the 2. Now we have to see how many 25s go into 212. And that's 1, 2, 3, 4, 5, 6, 7, looks like 8. So we're going to put our 8 above the 2. 25 times 8 was 200. and we have 12 left over, and we're going to bring down the 5, and this looks like it's going to work out perfectly. 25 goes into 125 1, 2, 3, 4, 5 times, and 25 times 5 is 125, and when we do the subtraction, you will have no leftovers. So the train has been traveling 58.5 miles per hour.